Welcome to the deep dive. You know that sinking feeling when you spend an hour meticulously cleaning up your Python type hints, getting MyPy to finally give you the all clear,
Mm.
only to run the program and have it just crash immediately with a type error.
Oh, it's the ultimate betrayal, isn't it? You did the right thing, you used the modern tools, and Python just punished you for it.
Exactly.
And today we're diving into one of the most frustrating, kind of niche, but really instructive errors in modern Python. The type error, type object is not subscriptable.
And this isn't just about using the wrong variable or something simple. This error, it really exposes a conflict right at the heart of the modern Python ecosystem.
Mm-hmm. It's the tension between static analysis, which wants you to be modern and use the latest syntax, and the runtime execution, which is, dealing with the reality of this enormous, sometimes slightly patchy standard library.
So our source material for this deep dive comes from the notes of an author who calls himself an old software plumber, a guy named Ang, who documented this exact problem.
Right. And our mission today is to unpack why this conflict happens, look at the specific technical standards that are clashing, we're talking PPs here, and most importantly, arm you with two solutions, one for a quick fix and another, more elegant one.
Okay, so let's jump right into the scene of the crime. The source material, it describes a developer who is just trying to do the right thing, resolving MyBia warnings in a big project.
Yeah, and MyBee, if you're not familiar, is that tool that reads your code before you run it. It's like a demanding friend who checks all your work to make sure your data types line up. It's what keeps huge projects from falling apart.
And this demanding friend, or maybe an AI assistant, sees some old syntax and says, hey, you should upgrade this. The developer does it, and suddenly, bang, a traceback right when the program starts.
Exactly. The crash happened in a function definition build subparser. The specific line that caused the whole thing to fall over was def build subparsers. Subparsers.argparse subparsers action any none.
Okay, so what are those square brackets doing? Any. That's the modern way to do type hints, right?
It is. It's a generic type alias. You're telling the type system, hey, this subparser's object is a container and it can hold, well, anything inside it. It's standard modern practice.
So the Python interpreter is loading the code, it sees those square brackets, and that's when it throws the type error.
Yeah.
What does it actually mean that this argparse thing is a type object that's not subscriptable?
That really is the key, isn't it? When Python sees square brackets, the subscript operator, it's usually for getting an item, like mylist 0.
Right, getting an item from a list or a value from a dictionary.
Exactly. But with modern type hints, like, listen, you're not getting an item. You're parameterizing the type itself. You're giving it more information.
Okay.
And for that to work at runtime, the class itself, in this case, argparse subparser's action, it needs to have a special bit of internal machinery, a method called class getitem.
Ah, okay. And that special method is what lets a class be subscripted with another type without crashing.
Precisely. But argparse subparser's action is just a standard class definition, a type object, and it doesn't have that machinery built in. So the interpreter sees the square brackets and just, well, it doesn't panic, but it throws the type error.
So it's saying, I see what you're trying to do, but this blueprint for a class,
Yeah.
you can't index it like a list.
You've got it. The MyPy fix was correct from a static analysis point of view, but the actual class just couldn't handle that syntax at runtime.
Which brings us to the bigger picture. This whole problem is a side effect of Python trying to modernize its type system, right?
It is. It's all rooted in a major language upgrade, PP 585.
Mm-hmm.
And a PEEP, or Python Enhancement Proposal, is basically the official way new features get designed and added to the language.
It's the roadmap.
The roadmap, exactly. So PP 585 came along and said, let's stop using the clunky typing. Listen and just let people write. Listen, it's much cleaner.
A huge quality of life improvement for sure.
Definitely. And when Python 3.9 was released, the core developers went and updated all the big built-in collections list, dict, set, tuple to support this new style at runtime. They added that class getitem method we talked about.
Not for everything.
But not for everything, and that's the crucial insight here. The standard library is absolutely massive. Updating every single class is a multi-year effort.
And argparse, subparser's action, was just one of those corners that got left behind in the update.
It's a perfect example. Even in Python 3.10, it wasn't updated. The built-ins got the treatment right away, but some of the older, more complex modules, they lag behind.
I can imagine argparse would be tricky. I mean, it handles command line arguments. It has a long history. You really don't want to break backward compatibility on something like that.
That's a very good point. Adding new runtime machinery for typing can't accidentally change the behavior for execution, so it's probably a case of being extra cautious. The problem is just a timing mismatch. My pyre is on the cutting edge, but the interpreter hits that specific class and finds itself stuck in the past.
So, we have a diagnosis.
Yeah.
The static checker is right, but the interpreter is crashing because a specific class is out of date. Let's talk fixes. Our old software plumber gave us two. What's a quick and dirty one?
Okay, so solution A is using what's called a forward reference. It's basically a simple workaround. You just wrap the entire type hint in quotation marks.
So instead of argparse, subparser's action 80, you just write it as a string. Argparse, subparser's action 80.
That's it.
But wait a second. If you put it in quotes, doesn't that completely defeat the purpose? Isn't my query just going to see a string and ignore it?
That's the clever part. You're absolutely right to ask that. By wrapping it in quotes, you satisfy the runtime interpreter. It sees a plain old string, not code to evaluate. It doesn't see the square brackets, so it never crashes.
Okay, so the runtime is happy, but what about MyP? How does it still do its job?
MyP is smart enough to handle this. It knows about these string workarounds. It effectively does a second pass where it goes back, finds these string-based hints, and evaluates them as if they were real types.
So it's like a delayed check.
A delayed check, exactly. It gets the information it needs just a little later in the process. It's a neat evasion tactic that keeps both the static checker and the runtime happy.
But the author, Ang, he wasn't a fan of this, right? He said it clutters the code.
He did, and I can see his point. If you have to go through a file and selectively wrap 10 different types in quotes just because they haven't been updated, it starts to look messy. It feels like a patch, not a real solution.
I agree, aesthetics matter. Which brings us to solution B, the more elegant whole file fix that avoids all that, quote, clutter.
Right. And this solution uses a much older feature, actually, introduced in PP 563. It's called postponed evaluation of annotations.
Postponed evaluation. That sounds like you're telling the compiler to just take a break.
That's pretty much what it is. And the implementation is so simple, it's almost funny. You just add one line to the very top of your Python file before any other imports.
And that line's...
From future import annotations.
So what does that one magical future import actually do?
A future import is a special directive. It tells the Python interpreter to switch on new language features that aren't the default yet. And when it sees annotations, it makes one sweeping change for that entire file.
Let me guess. It treats every single type hint as if it were wrapped in quotes.
You got it, automatically. Every type hint in the file is treated as a forward reference. You don't have to hunt down the problematic ones. It just fixes the runtime conflict for everything all at once.
Wow, okay, so that's much cleaner. You get to write the modern syntax you want, like argparse, subparser's action annie without the quotes. And that one line at the top ensures it doesn't crash at runtime.
Exactly. It's the cleanest, most robust way to bridge this gap between the new syntax and the older parts of the standard library. MyPy is perfectly happy, the runtime is happy. It's really the idiomatic solution for modern type-checked Python.
So the big takeaway for you, the listener, is if you hit that type object, is not subscriptable error. It's not you. It's not MyPy. It's this timing conflict in Python's evolution. And the elegant fix is, luckily, just 4 words long.
From future import annotations. It solves the problem with real elegance.
And speaking of knowledge and elegance, I want to go back to our source author, Ang, the old software plumber.
Yeah, his notes are really something. He writes daily on Python, Haskell, sure, but also fish keeping, gardening, even dieting. It's not just a programming log.
It's a life log.
It is, and it raises a much broader question, I think. We just spent this whole deep dive on one tiny, super specific bug, a conflict between two PPs. But think about the value of what he's doing, that consistent daily journaling.
He didn't just find a solution. He documented the problem, the context, to trace back the 2 solutions, and why he preferred one over the other.
Right. And that turns what could have been a few hours of deep frustration into a permanent, reusable piece of knowledge for him and now for us. So here's a thought to leave you with.
Okay.
How might dedicating yourself to documenting your own small, specific struggles every day, no matter the field, accelerate your own mastery?
Right.
That discipline of just writing it down. It's how you build a real library of expertise, one tiny specific node at a time.
That's a really compelling thought. A great reminder that solving these niche technical problems can teach us much bigger lessons. Thank you for walking us through all of this today.
My pleasure. Till the next deep dive.
We'll see you then.